Hi, everyone. Welcome to today's webinar. Good morning, good afternoon, good evening, depending on where you're at. We're honored today to have with us Lucas Smith. Lucas is a partner at Liip, one of the leading agile web development companies in Switzerland. He is part of their e-commerce team and has been part of the Oro community from almost the very beginning, actually from before the beginning when we were developing the product. He has a strong background in both PHP and Symfony. He's been developing with PHP since 1999. He was a co-release manager of PHP 5.3, and he launched wiki.php.net. Also within the Symfony community, he's part of the Symfony core team. He is the co-lead of the Symfony CMF initiative, and he is the creator and maintainer of dozens of bundles within Symfony. So we're honored to have him here with us today. We are looking forward to hearing from him. We're going to start the webinar by Lucas presenting, and then at the end we will take some time for questions and answers. We welcome you to actually type questions in the chat as you have them along the way for Lucas, and then what I will do is at the very end of the presentation I will curate the questions and make sure that we make Lucas answer them all. So with that, Lucas, over to you.
Thank you very much, Jari. Welcome as well from me. I've given quite a few talks. I think I've never done a webinar, so this is a unique experience talking to my screen and a wall behind it. But I will just imagine a lot of attentive people around the world listening, and then we should be fine. So without further ado, let's jump in. Resting with OroCRM. So I've prepared a small agenda. I would like to talk about REST theory because there's actually quite a few misconceptions that I keep encountering when people say they're RESTful or they're doing REST or things like that. Then we'll get into a little bit how you can actually find the OroCRM REST APIs, how you can use them, and then we'll also look at how to add your own REST API to OroCRM itself. So let's get started. Introduction to REST. So one of the things that I've realized over time, and this definitely applies to myself, is that people say a lot of things about REST, and many things that they say don't really make sense. And this is, I started from the very beginning. I had this idea that, if I install a mod rewrite in Apache and convert all my get parameters to virtual directories, that's REST. And at the same time, I didn't really understood why I should differentiate between how I pass parameters get and a post request. So that just seemed like academics to me. And it only really started making sense to me when I was starting to play around with Varnish, reverse proxy. And then I realized that essentially REST is about using HTTP in a very specific way to enable people on the outside to make assumptions about what you're actually doing or how your applications behave. So really it's a set of rules to constrain yourself by so that others can safely assume certain things. And in the context of a reverse proxy, that means, for example, that they can know what they can cache and what they should not cache. So not sure, I hope everybody has seen it that as a web developer, but so here's just an example of a request, how it looks sort of in text format on the wire. So this is a GET request on /nodes. Host is Symfony REST Edition. So this is sort of I created the Symfony REST Edition together with a friend from Berlin, which essentially just showcases a little bit how Symfony works. So this is just an example that would work inside of that Symfony REST Edition. We see various headers afterwards and so on and so forth. So this is essentially what you send over when, in a browser you go to a URL. This is what is being sent over as an HTTP request. Now, sorry, a response might look like this. So the response is telling us the version of HTTP protocol that is being spoken here. 200 means effectively that the server was able to respond, which effectively maps to OK as the string. And then again, we see lots of headers coming back, and then at the very bottom, we see a JSON response in this case. So this is sort of how HTTP looks on the wire. And if you're dealing with REST, then you kind of need to know about how things look on the wire, because you're going to mess around with this in a way that browsers don't really expose to you normally. So continuing on with explaining a little bit of the REST theory, there's a really nice model created by Martin Fowler called the REST maturity model. And it really helps sort of explain a little bit in sort of levels how REST actually works, and how you can actually apply all these different rules that Roy Fielding defined. So REST maturity level 0 is what Fowler calls the swamp of POCs. So this is not where you want to be. So this is using HTTP just as a tagging mechanism. So basically, you're just sending data to a single endpoint. And all the semantics is hidden away in whatever format you use to transfer the data. You don't really use the HTTP protocol at all. So in many ways, you could say SOAP is exactly that. So let's look at an example here. So let's imagine that it's a service for making appointments at a doctor. So basically, you have this appointment service, some URL, and you just post some data over there requesting a slot for an appointment to be reserved, and you just get a list back. And both of these, like the format is entirely up to the service. From the outside, nobody knows that you're actually trying to create an appointment there and that it was successful or not. Like, this is just not possible from the outside. You actually have to introspect the data that is being passed back and forth in the body of the HTTP message. So from the headers and things like that, nothing is really obvious to the outside what's going on. So at REST level 1, we introduce the concept of resources. So instead of just talking to a generic endpoint, you actually talk to a much more specific endpoint. So again, looking at an example, you might be wanting to reserve an appointment with a doctor called M. Jones. So instead of just going to the general appointment service, you go to Dr. M. Jones, and there you send your post request, asking for a slot to be reserved. And that means, at least from the outside, we now know who you're talking to, or the resource you're talking to. And then in the response, we get some information about the appointment URL that was then created, so that you have this as a token to later interact with your appointment. So at REST level 2, and this is in fact actually what most people say that they achieve when they talk about that they have a RESTful API, you begin to use what is called the HTTP verbs, and you also start to use the HTTP status codes. So some things are changing now in this example here. So where we always were using what is called a post, we now use a GET request, and we use parameters on that GET request to see, for example, which slots are even open. And then we reserve a slot, and we get back, a 201, which in this case means HTTP status created. So now from the outside, it becomes quite clear what we're doing. So in the first step, we're just getting the list of open slots. In the second step, we're actually reserving a slot. And then it becomes clear that we actually succeeded at getting such a slot. And then we also can see from the outside what the URL to that slot is. So again, from the outside, it's much, much clearer what's going on. Even without knowing anything about this particular service, just knowing HTTP, you will already be able to sort of figure out what's going on. Now, let's look a little bit in more depth at this concept of HTTP verbs. So we saw get and post before in the examples. So get is essentially reading data. The head request is essentially the same as a get request, but you basically just ask for the HTTP headers to be returned, but not the content. So if you say, for example, in the get request that we had before, get the list of open slots, you would in fact just get the 200 OK. You will not get the actual content of the list of open slots. Post and put are generally used to write data to a server. Delete is there to remove data from a server. There are plenty of other verbs. Option is another one. And in theory, you could even invent your own. But let's stay with these 5 that we have here. There are 2 things that are important to remember with all these HTTP methods. And this is if they're safe and if they're idempotent. And let's move on to the next slide to see what that means. So safe means that this HTTP verb means that the response can be cached. Idempotent is a little bit more complex. What that means is that the result is independent of how often you execute the given call. So let's go back again. So a get is essentially safe. So if you do a get, the result can be cached. And also, it shouldn't matter how often you do the get, you should get the same result. Same thing applies for a head request. A post, however, is not safe for caching. You're writing data to the server, and so that shouldn't be cached. Because if you write again, you do want this data to be sent to the server again. It's also not idempotent. So if you post multiple times, then you should not expect to get the same result or the same state on the server. So sending the data again, that might result in a different change. Whereas with a put request, you in theory can, just to be sure, send a put request twice, and it shouldn't have any negative effect, or at least the state should be predictable. Now, on the delete, obviously it should also not be cached. And here, some people say it should be idempotent, and some people disagree. Let me move back to the next slide. It fundamentally boils down to, do you believe, and this is something that actually, as far as I know, Roy Fielding has never clearly stated, is this the result, what is being referred in the specification, is that just the server state or also the HTTP response? So if I say all that I care about is that something is deleted and it doesn't exist on the server anymore, then if I send a delete twice, and so on the second time the resource is already deleted, then I would expect a 200. So everything is okay, resource is gone. But if I, believe that it only that the HTTP response can change for idempotent requests, then I could say for the second time when I do a delete, actually I want a 404 because I'm trying to delete something that isn't there. Now, I would say generally the web is, a disconnected place. TCP resends packets and things like that. So, people get impatient. They hit delete buttons multiple times, and it doesn't really make sense for them to then see an error. So, I think in most APIs, you probably do want to return a 200 on the delete. Now, there can be specific APIs where you do want to have a 404 if somebody tries to delete something that doesn't exist. But then I would also try and track if actually something has existed or not. So in the sense, you need to be able to do soft deletes in such an API so that you can actually determine if somebody is trying to delete a non-existent resource or if they're just trying to delete a resource that used to exist. So that's just something to keep in mind. Now, moving on, we're still at REST maturity level 2. HTTP status codes, and we saw these status codes in the responses and the examples before. There are different code ranges. So, for example, 100 is for informational purposes. I personally have not really counted it in practice. 200 is for response codes that basically mean that something successfully happened. So, for example, 201 means created. 300, that's for whenever you want to say that you reach a URL, I know about this URL, but actually you should have gone somewhere else. 400 is for a client error. So, for example, the classic 404, you're trying to reach something that never existed, and you shouldn't have tried to get there. The 500 is when something on the server side went wrong. So, advancing from REST maturity level 2 is REST maturity level 3, obviously. And there we introduced the concept of hypermedia control. This is essentially links that we are used from, just HTML. But the idea is that you should, in fact, in REST maturity level 3, be able to just traverse from some root node and find all the services that are available in the system. So you start off with, I go to, for example, the hospital page, and from the hospital page, I find a link to the doctor's page. And from the doctor's page, I see that there's a link to how to, reserve an appointment, and so on and so forth. So I basically, in theory, could have an intelligent, smart client that just finds and discovers the API on its own. And there are various different formats how to achieve that. Some for HTML, some for HTML, some for JSON or XML, and so on. Atom, HAL, JSON LD, and so on. These are all popular formats. And essentially, so if you look at this next slide here, this is essentially the same as what we did with REST Maturity Level 2. The difference is that in the responses, we will find link relations. And these link relations help sort of the client discover possible ways to interact with the API. Ideally, when you see here this link rel, these should be things that are well explained. There are some repositories that explain link relationships that you can use. Alternatively, you can of course create your own and document these in some place. Now, this REST Maturity Level 3, this is what people talk about when they talk about hate OS. Horrible acronym, but yeah, something to keep in mind. So this is what they're saying. Basically, link relations is the idea. So what the acronym really tries to transfer is that you explain the state of your system by embedding link relations, and you allow transfers between the state through these link relations. Now, we covered quite a bit of theory here, but so to some degree, I want to maybe put a little bit of a relativity spin on this. So first up, most people consider RESTful when they reach REST Maturity Level 2. And it's a decent enough approach to be fine with that. That being said, if you really want to be follow the REST specification as Roy Fielding defined it, you need to at least have REST Maturity Level 3. That being said, even the REST maturity model does not cover all aspects of REST, and we'll briefly get to what is missing in a moment. And what is also kind of interesting is that, especially from when I was saying that for me in the beginning, REST was all about making virtual directories out of get parameters. So I was totally focused on the URIs. Essentially, if you're at REST maturity level 3, how your URLs matter really almost nothing, because the URLs are just embedded into link relations, and you just follow them. You're not really looking at them. You're just following link relationships. Another thing that you should realize when you look at all the REST theory is that browsers make really bad REST clients. Essentially, they just support get and post. They don't support delete or put or any of the other HTTP verbs. Yeah, so that's something to keep in mind. Most of the time, if you really want to properly test REST APIs, you can't use it do it in a browser, or you need a special plugin inside your browser. Another thing that is just interesting to know is that REST, as Roy Fielding defined it, is actually protocol independent. So it's not really bound to HTTP, although I've only encountered it in the context of HTTP. And then finally, and that's quite unfortunate, and also one of the reasons why many people skip REST maturity level 3 is that there are very few clients that actually really leverage HateOS, and therefore, in many ways, you could say that REST maturity level 3 in the real world is still quite theoretical. Now, the next aspect of REST that is important if you want actually be RESTful is what is called content type negotiation. It's a little bit fuzzy. There are not really any clear specifications on how it actually works in detail. And it's not so important in the context of OroCRM. So I'm skipping this in this talk. I actually do have some slides on it. So if we are good in time, then I might go back and show you those slides. But I just want to make sure that you're also aware of this term. So with that, let's get into actually OroCRM and its REST APIs. So there are various different ways how you can discover the available REST API. So one very low-level approach is to use the Symfony console embedded in OroCRM. There's a command there called router debug, which basically lists you all the routes that are available, and all the OroCRM internal APIs, at least, they include the string API. So with by grepping by API, I just get all the REST APIs inside OroCRM. The router command is quite useful. You can once with that command, you basically get a list of all the routes, and you can pass in a route name into this command as an optional parameter, and then it gives you even more details on that route. So that's quite useful to know about. But there's actually a much nicer way to discover the OroCRM REST APIs, and that is based on the NelMyo API doc bundle. So if you have an installation of OroCRM, then you can just go to /API/doc, and you will get a really nice overview of all the APIs. It also includes a really nice sandbox, which allows you to try out API calls. And all this information is actually extracted from the controllers, mostly from annotations. Some of it actually is also from the routes. So here's just a quick screenshot of how that looks like. So basically, you have this list of all these different APIs. You can click on them to expand, to get even more details. So for example, here we see expanded API for the accounts entity. We see requirements, so you can pass in a format that can either be JSON or HTML. You can pass in a version using latest or V1, and so on. So that's quite useful. And then here, if you go into that sandbox tab, there you can actually type in, for example, here I typed in the format should be JSON and the version should be latest. And then you can try, and it will actually show you the response. So that's quite convenient to get started. Now, we saw these URLs, and they have these curly brackets, and anybody that has worked with Symfony a little bit has probably seen them already. This is actually Symfony applying an RC 6470 for templated URI. Symfony actually doesn't implement the entire RFC, but most of it. So essentially these curly brackets, they denote placeholders that you can fill in when you actually want to call the URL, or actually you have to fill in. So for version, again, as you saw in the require here, you have to have either latest or V1 in there. So if you construct a URL, it would be /API/REST/v1. Then in this example here, this is for the accounts API of a single account. So you also need to add the ID of the account at the end. And then finally, this curly bracket _ format. So this is a little bit of magic inside Symfony. Because you can actually omit this _ format, and then you would have to use an accept header with application JSON. And this is actually this content negotiation stuff that I talked about earlier. In this talk, I will mostly skip over that. But again, if you're interested in that, do read up on the details there. But effectively, if you don't want to use an accept header, you can just add .json to the URL. But if you don't, or if you do want to use the accept header, then you actually have to omit the dot before this curly bracket _ format. So it would be /API/REST/v1/account/1, for example. Now, for testing REST APIs on the command line, I would recommend a very simple client called httpy.org. You can, of course, use curl, which is available on most development machines, but this is a very nice client. It's open source and easy to install. It's based on Python, but yeah. So let's try out such a REST API, and the first thing that you'll encounter is a 401. And if you remember, that means it's a client error. 401 stands for unauthorized access, and this is because all the OroCRM APIs are actually protected by WSSE security, which is a standard that they've implemented in OroCRM. Effectively, what this means is that you need to create an API key for your user, and you need to create a specific header that you need to pass in with your request in order to pass this security firewall. Now, to generate such an API key, what you have to do is basically go to the user administration under the System tab in OroCRM and hit Generate Key. And this will generate you a key, like in this case, we have C51, etc. So this is your API key. And with that API key, you can use another command called oro::wsse::generate header. And as the first parameter, you pass in that API key. And this will generate you the headers that you need to pass in order to do a REST request. So it looks a little bit cryptic, but essentially you just call this command and it generates you such a header. There's actually pretty good documentation in the cookbook on the OroCRM website about how this works and the ins and outs. So definitely look that up when you're starting to work with REST APIs in OroCRM. Now, so after calling this command, I basically can run this command again and then just pass in this header, this XWSSE header, and then voila, I get a response. Yeah, so that's basically it, how to use REST with OroCRM. One thing, and that is sort of a little bit iffy in practice, is that these headers, this X-WSSE header, so this only works once. So basically, with every time you want to test something, you need to generate such a header again. So this is really a little bit cumbersome. But there's helper methods to, and these are explained in this doc link that I sent, how you need to basically embed that into your own code. So in your own code, you will have to put in some logic to generate these headers based on this API key. It's just a few lines, like maybe 10 or so, that you need to embed into your REST client. So here's another example. This time we're posting. So with this HTTP client that I have here, basically with this smaller or greater sign at the very end there, I can basically pipe in the content of a file, and then basically that would overwrite part of this existing account. And actually, I see I did a typo there. So instead of a post, this should have been a put, because I want to write to an existing account. I don't want to create a new one. So that's basically how you read and write. Let's briefly look at how that works in practice. So let me jump out here and jump into the shell. So essentially, I just run the command here. I copy this header, and then I have my request here. So I'm requesting all the accounts. Let me remove the old XYCZE header. 1 second. There we go. Paste. And if I run that, I get my result. If I run it again, as you can see here, I basically get an unauthorized error again. Right? But here I basically have, a JSON response giving me the information about all the accounts that are available. By the way, there is paging also in this REST API. But yeah, anyway, so that's basically it. How you can, read from the REST API. Pretty straightforward. So let's get back to the presentation. So obviously, when you're working with OroCRM, sometimes you want to add new APIs. There are actually quite a lot of REST APIs already, so I can't really say a number, but I would just guess that 80% of the entities that are in there already have REST APIs. But some don't. And also sometimes you want to add your own entities, and so you might need to create a new API for OroCRM. Now, OroCRM also supports SOAP, and their long-term vision is to really make it easy for you to create REST and SOAP APIs with minimal amount of code. So the OroCRM developers are actually gone through a few iterations of how to best build REST APIs. They're currently working on a class called Entity Serializer, which aims to really make it super trivial to build REST and SOAP APIs with the same controllers. The current most used approach is using the REST GET controller as the base class, and that provides various helper methods. It's quite simple and very straightforward. Actually, that's what I'm going to show in the next examples. But it's also quite limiting in terms of if you have very complex graphs that you want to serialize to JSON. So there are more advanced serializers that you can easily pull in. And actually, I think at least the JMass serializer is available as part of OroCRM out of the box. And I think the Symphony Core serializer as well, but both of them are easy to add via Composer. And they have very thorough documentation explaining how to use them. But anyway, I will show you the REST GET controller approach in the next slides. So let's imagine we want to build a REST API for the cart entity. So the cart entity is part of the Magento bundle, which basically makes it very easy to integrate Magento data into OroCRM. So with this Magento bundle, you can very easily import cart data and orders into OroCRM. But for some reason, they have not included REST API. So let's build one. So first step is I basically create a new controller, cart controller, in a new bundle. You can, for example, use the generate bundle command for that. We're going to extend the REST controller from OroCRM. As you saw, it actually is part of the SOAP bundle. So that shows that the OroCRM guys have actually already done some work in order to get REST and SOAP to work from the same base. The REST controller itself extends from REST GET controller. So this brings in all these helper methods that I talked about. Then this implements the class resource interface, and this comes from the REST bundle, and this is something that will help us generate routes automatically, essentially, by following the naming conventions or methods. It's not required at all to use that. You can also manually define your routes, but I will show you how that works in detail. So now let's build the first API, and that is for returning a list of cards. So what we do is we actually, so we have a doc block here, and this API doc, this actually is for this API documentation page. So here we just add a description and say that this is a resource. Next up, we have another annotation, and this is for the OroCRM permission system. So we basically say that you can only access this API if you have the OroCRM Magento card view ACL. Finally, we just say that this is going to return an instance of JSON response from Symphony Core. The code itself is quite simple because we're using these helper methods from the getREST controller. So basically, we get the manager, we get a list query builder, we query and we execute that query. Then we pass that on to a get prepared items. And this is sort of, this is where the magic happens of serialization, essentially. Or let's say not exactly serialization, but converting the result of that query into an array. This method basically takes two parameters. So one is the collection of entities we want to convert to an array. And the second parameter is a list of fields that we want to include in that resulting array from these entities. On the next slide, we see that this fields is, in this case, the ID, the subtotal property, the grand total property, tax amount, and customer. We could add and remove whatever amount of fields we want, and then they're included or excluded from the result. Also, what you can see on this slide here is, all the different classes I needed to pull in order to build this method. So here we see, the ACL ancestor. This is from the security bundle of OroCRM, the REST controller, and so on and so forth. We see all of that pulled in. Now, there's actually something that is still missing, and that is we need to implement the get manager method. The get manager method is basically, or the manager is responsible for fetching the entities for the card. And so we need to have a manager dedicated to the card. And I will show you briefly how to build that service. It's actually very easy a little bit later on. The other thing that we need to do is there's this transform entity field. And this is because oftentimes entities actually have relationships. And when this method, this get prepared items method, encounters something that isn't a scalar or an array, it will actually look at this method here, transform entity field, and we'll see if it can transform this into something that is an array or a scalar. So in this case, if we encounter a customer, then we just want to get the last name and put that into an array and return that. So that's quite simple. As you might notice, we actually don't really return the value. This is because the value is actually passed by reference. So by manipulating the value that we assign to $value, we basically return the data. So with that, we basically have listing implemented. Let's implement another method. So this is the get action. This is for just getting a single card. Here we have a parameter called $card ID, which we then pass on to the manager. And then instead of using the get parameter prepared items, we use get prepared item. So for a single entity, we pass in the fields again, and that's it basically. So one thing I've glossed over actually is the method names. These are actually very important that you follow a naming conventions here if you want to use this automatic route generation. So this method here is called get action, and the other one was called cget action. And that's basically, the C stands for collection. So basically what the syntax means is this is a get action. So this should use the HTTP verb get to read. And the first one is a list, so a collection that we're getting. And the second one is a single entity. Another thing that is important is the name of the controller. So this is a card controller. So that basically means that the FOSS REST bundle automatically understands that this is actually, the entity is a card. And so if you do /cards and access that, it will give you the list. If you do /cards/ for example 1, it will get you that one card instance. So here is actually the full code that we need to implement an action to get a list of all the cards in the system, and an action that gives you a single card and serializes that into JSON. So that's pretty simple. As you can see here, there's also a method for forms, and this is in case you want to implement write APIs. I don't have an example in this talk here because it would just take a little bit too much time to explain it. But essentially, to do writes, you basically have to implement your own form handler that basically accepts a JSON or some other request data and transforms that into a card entity to do writes on the database. Now, there are a few things that are missing here. So the first thing is we need to define this ACME Card Manager API service. That basically uses the OroCRM Card Manager. So actually, I have a typo here in the class. So this is there's an API entity class that you can just use from the SOAP bundle to build your manager instance. You can then extend from the entity manager from the SOAP bundle, and all you have to do as a parameter is the card class name, and that's it basically. So that's all you need to do to define your service. So let me quickly fix some typos that I created here. So this should have been ACME here, and this should have been there. Okay, there we go. Typos fixed. Yeah, so for the entity, for the card entity, there's already a parameter defined in the Magento bundle, so we don't need to define our own. But for the card manager, we need to define our own. So that's what this does. So pretty straightforward. Then for the routing, here we use the forced REST bundle routing. And this is, again, this is going to introspect the name of the controller and the name of the action methods to automatically generate routes for us. So in this case, we see, so we have as a resource, we have a reference to the card controller that we created. We define type REST. So this uses the FOSS, basically means that that it will use the FOSS REST routing loader. And then we add some more configuration. So the prefix is that we say API REST version is a prefix. And we say requirement, the version has to be either latest or v1, and we default to latest. So if you don't specify a version, it would automatically use latest. So that's it, basically, to build our API. From the command line, we could then start using that API right away. Yeah, but let's look at briefly how to actually do that in the test. So OroCRM also provides some helpers to build functional tests for REST APIs. So they have their own base web test case class that you can extend from. Here in this example, I also copied a method from the Bazinga REST Extra bundle, which is assert JSON response. It's quite convenient to just be able to check if something is a valid JSON response. Then the first thing I do in the test case is I initialize a client and I pass as a second parameter a set of headers to generate the WSSE auth headers for us, so that automatically it will pass those in whenever we do a request. Now, to test the cards, for example, we will do /API/REST v1/cards, so that we send over that request. We can check if that was a successful response. So in this first case, I actually do a head request. In the second, I basically actually do the proper get, so it will get me all the data, and then I can check if it's a valid response, and then assert equals here, this dot dot, this would actually be a list of accounts, of cards that I would test again. I just removed that to keep the slide a little bit more readable. In the second example, you can see actually how that would look a little bit more in detail. So here we do a fetch of a specific card, and then in the assert equals we see, okay, does the content actually equal what we expect it should match. And that's basically it. That's how you can test your newly created REST API. So let's also look on the command line how that would look. So we basically we can just let's go back. So if we do cards, we get an authentication error as expected. So let's generate a new header. Let's generate this. And now we get a nice list. We can also look at this test. So let's run the test case. So here, this is the test case I created. So we have two tests. Both are passing. Great. So let's go back to the slides. So basically, I've already shown what I wanted to show, and we can move over to questions. Effectively, but maybe first we should briefly review what we looked at. Let's jump back. So we looked at some of the theory. Most importantly, we looked at this REST maturity model. So remember, level 0, swamp of POX, basically means you're basically just piping data over HTTP. You're not really using any of the HTTP features and so on and so forth. Level 1, you're using resources, so proper URLs. Level 2, you're using HTTP verbs and status codes. Again, this is what most people mean when they say that they're building a RESTful API. Level 3 would be using hypermedia controls like link relations and so on and so forth. Then next up, we looked at briefly how to discover REST APIs that are part of OroCRM. So basically, you go to /API/doc and you get a nice overview. You have the sandbox, which allows you to try out APIs and so on and so forth. Next up, we looked at how to actually build or how to use such a REST API. So for this, you need to generate an API key, use the Oro WSSE generate header command, for example, to generate that header, and then you can pass that on. Alternatively, as I explained, you find on, where did I have that? Here, that link in the cookbook. So that shows you the code. Actually, I can show you here in the browser briefly. So if you go here to this documentation, it shows you how to generate and so on and so forth. But it also shows you the PHP code you need to embed if you are building a PHP REST client that is supposed to talk to OroCRM. Then next up, we looked at how to build a new REST API. Turned out to be fairly straightforward. Just a few lines of code, we can build very quickly a REST API for listing and all cards as well as a single card. And then finally, we looked at how to test an API, basically using the init client method and the generate WSSE auth header method to easily authenticate us in our functional tests. So I'm done, and yeah, now I would like to take some questions.
Great, thanks so much, Lucas. Great job. I am going to jump in and curate some questions here for you. Start with some questions about REST. So why not simply integrate with other systems via common database and views? That's one of the questions we have here.
Okay. So oftentimes I encounter when I see people developing applications, instead of building a REST API, they just read directly from the database, and that has several problems. So the first one is that you're bypassing authentication mechanism, and therefore you basically bypass the ACL system of OroCRM. It means that you might be exposing more data than you really want to. Second is that these external applications might not follow the business logic that you want to follow, so they might screw up your database structure. And finally, you might change your database structure, but it's much easier to keep your REST API intact. So basically, it means that if people interact directly on the database, then they might have backwards compatibility problems when you change your database. And then, lastly, I think that actually is the most important is you don't want people messing around in your database. That's your responsibility as an application developer. And it's also, just for scaling and things like that, with a REST API, you can put a reverse proxy in front to, throttle people, to provide caching and so on and so forth. Whereas if they directly access your database, they might overload your system and you might be out of luck.
Okay, great. Perfect. And just reminding people, you can ask your questions here in the chat. Another one here, what is the advantage of using the application/JSON over just using the JSON ending on the URL?
Okay. Yeah, so this brings us back to this content type negotiation topic that I skimmed over. And let me actually enable those slides briefly. So the idea is essentially in REST is that you work, or these URIs, they identify a resource. And the problem is if you use .json, then you make it appear that it's a different resource based on format. But if you, for example, this, /account/1, that is a resource. And it shouldn't matter which format you ask of that resource. So if you say /account/1.json to, a reverse proxy, that looks like a different resource than /account/ 1/XML, even though they're just different representations. And one of the ideas that Roy Fielding embedded in the REST specification is that you actually work with resources that are identified uniquely, independent of their format. So the idea is that you can define media types, and you pass these media types in as request accept headers. And instead of adding, the output format to the URL, you add those as in a header. So here in this example here, I, for example, say accept header application JSON. That just means to the server, okay, I need to return JSON. And so, I think it's, many people feel that this is quite academic, and I think in practice it is quite academic. So that basically is the fundamental idea. One other thing that is kind of nice, but I also see it rarely used in practice, is that if you use an accept header, in theory, you can also do things where you allow people to request different formats in one request. So they can basically say, I want JSON, but if you don't have JSON, I will also accept XML. So this is what this example is about. And you can actually also use the accept headers for versioning. So in theory, what you can also do, instead of embedding the version into the URL, which again is sort of a violation of the REST specification, you can put those into accept headers. So you can have an accept header that says, I want version 2 in the format JSON, but if you don't have version 2, I will also accept version 1. And it's a quite complicated topic, and it's one of the reasons why I skipped over it. So if you're interested in that, I do recommend that you do some research on the topic of content type negotiation. Hope I answered that question.
Great. Yeah, it was great, Lucas. We only have time for one or two more, so I'm going to give you a more difficult one. How do you deal with performance issues, maybe during development and even after development?
Okay. Yeah. So during development, so one of the things that OroCRM does and that I showed is OroCRM uses annotations quite a lot. And there's one drawback to using annotations is that whenever you change your controller in development mode, Symfony will detect that you changed it and will think that maybe you changed something in an annotation. That means many times when you change a controller, it will actually clear the cache. And since OroCRM is quite a feature-rich application, regenerating the cache can take quite a lot of time. So during development, I actually tend to prefer to use the production system or the production environment, and only if I hit a bug and I want to get some more details about the stack trace and so on and so forth, I switch to development environment. I talked to Dima, and he said they're working on something to actually mitigate that issue. I assume that they will try to sort of introspect if any of the annotations have actually changed and only then clear the cache. But yeah, so that's something to keep in mind during development. Then later on in production, with REST APIs, again, if you follow the REST specification quite well, you can start leveraging what is called a reverse proxy. So Symfony itself comes with a reverse proxy implemented in PHP, which is quite easy to enable and use. So just search for HTTP cache in the Symfony documentation. You'll find some information. I often use Varnish, which is a very high-performance reverse proxy. And so with such a reverse proxy, you can cache quite a few of your GET requests, maybe just for a second or 2 or 3 or 5. And with that, you can already reduce the load on your system quite a lot in production. It depends, of course, on what type of request you're getting. If you're getting a lot of writes, then optimizing performance is naturally very hard. But if you have, a fair chunk of reads, then especially with the reverse proxy, you can solve quite a few performance issues.
Great. That's fantastic. Well, I think that concludes our time. We had a couple more questions, but maybe we'll just follow up via email with those. But thank you so much, Lucas. Thanks for being on, and thanks for presenting this. And we look forward to seeing you on a future webinar. Thank you very much.
Yeah, thank you as well, and bye-bye.